Okay, so we're in the unit called polynomials, and this was yesterday's goals. And so let's just see if you learned how to identify whether something is a polynomial and what the leading coefficient and behaviors are. There's a couple other little things I taught you yesterday. All right, so here we go. Here is a polynomial. Y equals negative 5x squared plus 7x to the third minus 4. I'd like to know a few things. Number one, what is the lead? I'm just going to not have the connector words here. What's the lead coefficient? Number two, tell me what's its degree? Number three, how many terms does this have? Number four, what would its right and left end behavior like? Is it going up or down? The correct answers are like up and down for those, okay? On the right, it's up, and the left, it's down, or whatever it is, okay? Number five, I'll pause for a second while I answer those first four. Okay, and I'm adding on two more questions. What's the constant, and what's the y-intercept? All right, I'm going to pause for a minute while you give that one a shot. Okay, so here we go. The lead coefficient, you should have not been sucked into thinking that's the one that's the lead coefficient because it happens to be in front. No, this one is the lead term, and therefore that is the lead coefficient, 7. The degree, once again, the biggest one wins. That one, not this one. So it's the 3 degree. How many terms does it have? That, and that. 3. On the right end, since this is positive, the lead coefficient is positive. That means it has a happy ending. Positive means like up and happy, right? So up. And then the left end, since it's an odd degreed function, somebody who has their hands, like here's a stick person. Somebody who has their hands like this, that's pretty normal, right? They're raising their hands. Okay, that's even. And this is not normal. It's odd. If you're going like this, it's more odd than raising both hands. Okay, I know I'm stretching it a little bit there, but anyway, a function that goes like this is an odd degreed function, or of course the other way. But this kind and this kind are even. They are the same. They are even. If I said these two people are in a race and they're at the same speed, they're obviously even with each other, right? Same and even kind of makes some sense. And different and odd, if you said, well, she's kind of different, that might mean she's kind of odd too. All right. Anyway, odds, evens. So what's this one? Odd or even? This one's odd because you pick the biggest degree, and it's that one, and that's an odd number. And therefore, it's odd, and therefore, they should be going different ways, right? One's up, the other's down. How many of you had that right? I need to get perspective on how many understood that from yesterday. Good. And the last one is constant. The constant is -4. You got to include that negative. And then the y-intercept. The y-intercept is where what? X equals 0. So if I stick in a 0 here and a 0 here, all that cancels, and it's the -4 again. How can that be? Can there be something that's two things at once? Of course. All right. Last thought. What if this had been written like this? Now, what degree is it? Degree 3. Why not degree 2? The biggest exponent's a 2. When you multiply it out. If you multiply this whole thing out, you'll be able to see the biggest degree. And the biggest degree, this x would become squared because of that, and then it would be multiplied by that x eventually, and it would become an x to the third. Okay, if you multiplied it all the way out, you'd have an x to the third. Therefore, its degree will be degree 3. All right, so I'm going to ask you a few questions about one in this form, and here it is. I'd like to know Number 1, what's the lead coefficient? Number 2, what's the degree? Number 3, I'm not going to ask how many terms it is. You could do it, but this kind we wouldn't probably ever ask you that. We would definitely ask the end behavior. As in left side, that's a terrible L, and right side. When you're done with that, for your next trick, you will be needing a graphing calculator. If everybody could grab a graphing calculator, take it out of your backpack or whatever, that'd be good. The lead coefficient, yes, sir. You thought it was 3. All right. If you multiplied this thing all the way out, would there be a 3 on the lead coefficient? Yes, but who can tell me more? Yes, sir? Because this negative x is, wait a minute though, that negative x is going to get squared. Oh, I got fooled by that too. I thought she was wrong because I thought I was going to say it's negative 3. I think it is positive 3. Because once this gets squared, that negative x is going to be multiplied by a negative x and become positive. And therefore, yeah, it is positive 3. Sorry, I doubted you for a moment there. I don't know if you even thought through that possibility, but anyway, that negative in there could have destroyed that, but it didn't. Okay, on to degree. Now, if multiplied all the way out, what would the biggest degree be? Degree 5. That's correct, because this one would be an x squared, and this would be an x to the 3rd, and when they get multiplied together, they would make an x to the 5th. Therefore, the degree is 5. All right, next thing is end behavior. Now, is that negative? Because it's in there being squared, is that negative going to matter? Okay, so it all bases off that lead coefficient. And so the lead coefficient is a positive 3, as we determined, because that negative won't matter. Then it's positive, and therefore the end of the story, on the right end, it's always a positive ending is going up. And then, since this is an odd degree, there would have to be opposites, and this would have to be down. Because once this is determined, always do the right side first. Once that's determined, then you can just decide whether it should be the same or different. And if it's odd, it's different. Yes? Okay, x is cubed for the second part of the equation, but you got to multiply the whole thing out. So this would be an x cubed, which would then eventually get multiplied by that x squared, which would also then eventually get multiplied by a 3. This 3 being in front would have to multiply by both parts. Therefore, the 3 would be on the x to the 5th, and therefore the 3 is the lead coefficient. All right. And the only way you could prove me wrong is if you actually multiply that whole thing out, and when you get it done, if the x to the 5th really only has a 1 on it, then you're right. But I'm 99% sure that it's going to have a 3 on it. I'm only leaving that 1% because I respect that you're a smart kid and you might be onto something. But all right, I'm moving on to the lesson for today. Oh wait, no, I'm not. I'm going to remind you of the problem we did from the lesson yesterday, and then show you another one like it. This one. Do you remember this one? All right. So I had said draw picture is really important, right? They already had a picture for us. Cool. This next one for today, I'm going to make you draw the picture, and it'll help you because that's one of the things you'll have to be able to do in the test is draw the picture. Okay, the next thing. You were supposed to do something else, and this is critical, otherwise you cannot solve this problem. Set up a what? Equation. And to do the set up equation part, you should really start with an equation. And you got to figure out what equation are we doing here? Is this area, volume, surface area? What is it? This one was volume. And so here's the pure form of the equation. Always start with the pure form of the equation. All right, now use what the skills I just taught you yesterday, and even the day before that I talked about it a little bit, in order to set up, times height, thank you. If we use those skills on this next problem, hopefully you can solve it without any help from me and without any help from anybody else, not a partner one, okay? Your graphing calculator will be employed at some point. Just to clarify, remember last time you graphed this and you found its highest spot. But if you have two numbers on both sides, if this had been like a 150 or something, then you would have graphed both sides. You graphed this side and that side, y equals 150 and y equals whatever the big equation comes up to, which remember on this one, it was 12. For this side, it was not 12 minus x. That was a really common mistake. It was what? 12 minus 2x. And this side was not 10 minus x. It was 10 minus 2x. Okay, so anyway, once we had the thing all multiplied out, you can graph both sides and see where they cross. Given all that, I'm going to tell you only in words, which I can repeat for you if necessary, a situation. The first thing I would do is draw the picture. Okay? Have you guys heard of an 8 by 10? That's a size of picture. Okay? You have an 8 by 10 picture. And you have an obsession with the number 100. And so you decide, as you frame this picture, you're going to have a little frame, rectangular frame around the outside of this picture. You're going to frame it, custom framed, so that the area total, including the frame, is 100 square inches. Exactly 100. So then, my question is, how wide should the frame be? Little piece of wood that you're going to put around the outside of your picture. So the first thing you need to do is draw a picture. And obviously it's a rectangle, and I said it was an 8 by 10. We're going in inches here. 8 inches by 10 inches. All right, see if you can draw the picture, then find a pure form of the equation, then stick your numbers into the equation. You know that the area we want is 100. And then try to figure out what x should be. Hopefully, you'll use some common sense constraints about x. If you figure out that your frame should be 100 feet wide, then something's probably wrong. If you figure out your frame should be, I'm not going to say all the possibilities, but only choose numbers that could possibly work. 100 is the area. Picture was originally an 8 by 10. You're adding a frame to it. All right, I'm going to pause for a minute and let you struggle with this a little bit. I'm sure that some of you will succeed and a few of you will not. But even the struggling with process is good because it's been proven that then when I show you how to do it, you will remember it better than if I just show you right now. Okay? Give it your best shot. I'll pause while you try that. All right, so let me see if you had some of these elements right. 8 by 10. 8 this way, 10 that way. I'm going to put them on the inside actually because then it leaves room for my frame. Then did you realize, I know I heard somebody explaining it to somebody else, you can't just say this side is 10 plus x, can you? Because the frame sticks out this way and this way, it's 10 plus 2x. Raise your hand, how many of you caught that? All right, less than half of you. So there you go. It's an easy mistake to make. It's a classic. It's one of the reasons I'm doing this problem with you. All right, so next, go this way, of course. Now you can tell me. What's this way? A plus 2x. Okay. Then I needed the pure form of the formula. Now, do you get how if you just had a slipshod drawing, that's probably not a saying used nowadays, but a drawing that was not very careful, you might not have noticed that there's an x this way and an x this way. If you are careful with your drawing, you're more likely to catch little things like that. Okay, there's also an x that goes this way and there's an x that goes that way. So if you were really careful with your drawing, you probably were more likely to be the kid who caught that it was 2x. All right, they need a pure form of the formula. Area equals length times width, or base times height is fine. Then, Mr. V, put it all together into one formula. Okay. Keep going. There's more. Notice that A sticking out there? It's really important. Equals 100. Perfect. You have to have that or you could not have solved it right. Because otherwise, how would you take into account? I said it had to equal 100 if you don't include the 100. Okay, then You can graph both sides and see where they cross. That's the easy way. You graph that, and if you haven't already done that, please do that now. Y equals this, and y equals that. Maybe I say this is y1 and this is 2i2, or vice versa. It doesn't really matter. All right, to save some time, I'll get to it. You should have had a graph that kind of looks like this, and then another graph that kind of looked like this. And do you get that one of your answers comes out negative and therefore can't be because x can't be negative? Does that make sense to you? It's so easy to forget that and just go do the math on it and go, okay, here's my two answers, cross here, cross there, and just write both of them down. One of them can't work. That's called extraneous. Okay, so then the other answer that actually did work, what was it? 0.52. Can anybody verify the 0.52? All right, good. So 0.52 comma, I happen to know how high that is because it says 100 right there, and I graphed y as 100, therefore y must be 100. And it makes sense. 100 is the area. 0.52 must be the amount of the squirrel that I should eat in order to maintain my weight. Okay, maybe not. What is the 0.52? In the context of this question, it's what? Not just inches, it's the what? It's the width of the frame. It's how big the frame should be. So always try to relate it back to the actual question, because you could easily be fooled into thinking, you know, like negative 0.2 or whatever that was, would have worked in the context of a different question. But in its context, you can't have a frame that would be negative. In this context, does a frame of 0.52 seem possible? A half-inch frame. Yeah, that seems doable. 0.52, realistically, nobody's probably going to pick that. But if you had this obsession with 100, you'd have to make it 0.52 to make it actually have an area of 100. All right, that's another typical question. Notice the parts. A picture that's labeled really well. A formula that you start with that's pure. And then you stick the stuff from the picture into your formula. And at the end, oftentimes, solving this, which could usually be with a calculator. All right, so that's one of the big things we're working towards for this next, like in the future here, okay? Not necessarily this next test, but the next few tests. You can have word problems, and I want you to be scared of them. They actually aren't that bad. They're not impossible. All right, this is just a reminder that things where the a term, the lead coefficient, is bigger than 0, or wait, sorry, not the a being the lead coefficient. I'm sorry. Then it tells you the right end is up or the left end is up. If you have an even degreed polynomial, if you have an even one, then they're either going to be both up or both down. And if you have an odd degree polynomial, where the n is the degree of it, which I just wrote over, the odd ones look like this. We've already got that down, right? Tell me we've got that down. Okay, good. Then the last part that I need to teach you then is I'm going to do a brief description of the intermediate value theorem. This is something that you actually use in calculus. That's one of the things we try to do with honors pre-calc versus regular pre-calc, is we show you some of the calculus ahead of time. The research does show that you will learn it better when you get there if you've had a chance to see it once and process that. All right, so the intermediate value theorem says that basically between here and here, if this function is continuous, a continuous function, do you get it has to hit every x value and y value in between there? Because you can't just skip over a y value. Like if you skip over this spot right here and say, I never hit that spot, then there'd have to be an empty spot in your gap, and you'd have to have a gap in your function. It wouldn't be continuous. Does that make sense? All right, so to be able to prove that something is continuous, you use the intermediate value theorem. I think I just said that wrong. You can use the intermediate value theorem given the thing is continuous. All right, so what's the other option? If it's not continuous, it must be discontinuous. So how can you have discontinuity in a function? Well, the function can run along between here and here, and just go nicely and, connect the dots. That's continuous. What if it goes like this? It goes along nicely, then stops, starts over again right here where it left off, and keeps going. It hit every single x value, but it skipped some y values. You get what I'm saying? Is it continuous? No. The point is there's lots of ways to be discontinuous. This is one way where it hit all the x values, but it never touched some of the y values. Okay. Another option, of course, is to hit all the y values and never touch an x value. That would look something like this. Hit every y, but I didn't touch one of the x's. How about this? Now, do you get at some point it was every y value? Is it a function? It passes the vertical line test. It passes the vertical line test. It is a function. This dot is in the same spot where that empty spot is. So it is a function. And it's just not a continuous function. This is another way you can be discontinuous. If I wanted to give you the baby way of saying it, it's can you draw from here to here without lifting your pencil? Okay. All right. Now there's another way that you could be discontinuous, and that would be an asymptote. If there's an asymptote running along here, you get, I'm going to go from here to here, and oh, I can't get past that, so I got to go whoop up like this, and then from here I could be coming back and go, oh, I can't get there. There could be an asymptote stopping you. That's another way to be discontinuous. Yes, sir? Ah, okay. The question is, if the dog is a small dog, and it's eventually going to be a big dog, won't it have to be everything in between? If it's like a 4-inch long dog and then it's going to be a 10-inch long dog eventually, won't it have to be something in between the whole way? You'll have to be bigger and bigger and bigger. Can you just skip any sizes? No. Well, actually, you could. You could saw your dog in half and then add in an extra part of dog. Yes, this is the same guy who had the inside-out teddy bears. But if you put in a part of a poodle or whatever, the extension poodle, yes, he would instantly go from 4 inches to 10 inches. But it's just sick, and it's not continuous. Okay? All right. And I know those sometimes they help you to remember the topic better, but no dogs were harmed in the attempt to show you this problem. Okay. So I am not going to establish that the square root of 2 is a real number with the intermediate value theorem, but that's something that you could do with calculus. All right. And moving on. Now I need to get to this part because we have a shortened day today, and this is the new thing for today. It's really not very new, actually. You have been doing this for a while now. If you are remembering your pre-calc from last year, excuse me, your honors higher algebra from last year, do you remember that this was called a cut-through? And this was called a bounce? Do you remember that? Okay, good. Well, there was a third way, a snake. Very good. And that's where if I wanted to do this on the same function, just to keep the example going, the snake would have to be decreasing at a, let's say I make it go decreasing at a decreasing and then change to decreasing at an increasing right at that spot. That's called an inflection point, where it changes the way it's decreasing or the way it's increasing. Like if I draw it this way, here's another snake for you. You've seen this one before a whole bunch of times, x cubed, right? Then that's a triple root. This is a single. This is a double. This is a triple. And it can be hard to tell if it's a triple or not, and you may ask me on the test, yeah, I'm not. You can't say which kind is this, because you forgot it's a triple. You could say, is this supposed to be a triple root? Because it can be hard to tell from a drawing like this. But do you see that this is decreasing the entire time from like here to here? And do you see it has changed at that point from one kind of decreasing to another kind of decreasing? All right, that's how you can tell it's a triple. All right, so why do we care? Because if you have an equation that does this, let's say it triples through here, It goes and bounces off of here, and then it just cuts through at the end. Better extend this out a little further. I can write the equation for it. Let's say it's hitting at, it's not at 0, I guess it's at 1 there. And let's say that this is at 10 that bounced. And over here, if that's 1 and 10, maybe this is like 19, it cut through. Then the equation for it would be this, except I'm going to purposely make a mistake. And you'll see if you can catch me in it. Y equals, I'm only going to make one mistake, I hope. X minus 1. And since that's a triple, what am I going to do to it? To the third power. Does that ring a bell? You remember that? Okay, and then this one is 10, and so I go x minus 10, and that one's a double, so squared to the second power. And then last but not least, I have my x minus 19, and that one's just a plain old cut through, so I'm going to put it to the 1. You might be thinking, what could you have possibly done wrong? That seems like it's all right. Somebody will catch it. Okay. It's going down on the right. Oh, I'm clarifying. I shouldn't have taken your answer quite yet. You said it's going down on both sides, and therefore it should be even, right? Okay, but wait. Is it even or not? You got to multiply all of those together, x to the third and x to the second and x to the first, and that does make x to the sixth, so that's actually not a problem. You want to clarify? Okay, is it because it's going down on both sides that it's negative? It's going down on the right end, and therefore it should be negative. Just to clarify, only the right end is what defines whether it's negative in the front or not. Only the right side. The left side could be going up or down, and I wouldn't care. That matters based on it's odd. They must go opposite directions. This one's even because 3 plus 2 plus 1 makes degree 6. So since this one's even, they both have to go the same way. And it's going down on the right was the key. That causes me to have a negative right there. Okay, good. That's the main stuff for today. Now, here's how you get smarter because you're in pre-calc. Otherwise, it's just a review. Couldn't this also be degree 5? Because how would you tell the difference between a degree 3 and a degree 5? There's no like special drawing for a snake that's a degree 5. It's going to be the same. It's going to look the same. In fact, you can't really tell if that's a degree 3 or a degree 5 or a degree what? 7 or a degree 9. Okay, so you don't know for sure. From just a drawing, you can't tell. In fact, this one here that says the balance, and we used to just tell you in higher algebra that it was a degree 2. And I think in my classes I slipped this in. I would say it's a degree 2 or a degree 4, or it could be degree 6. We don't know for sure, because if you graph x to the 4th, it looks strikingly similar to x squared. That's x to the 4th. It's just a little narrower than x squared. So you can't really tell if it's bouncing, whether it's degree 2 or 4 or 6 or 22. Degree 22 would be the same thing, just a little narrower. A lot narrower, actually, but it'd still be bouncing. Okay, so why do you care? Because this multiplicity thing could show up in a picture, or it could show up in an equation. Like I could give you an equation and say, what's it doing at 3? And I'll just throw an x in front. What's it doing at 3 on the graph? And you would say, it's bouncing. Yeah. I could say, what degree is this polynomial? And hopefully you wouldn't say 2. What degree is it? Degree 4, because this has a little 1 on it, and this does too. Degree 4. Okay, therefore, how about the ends? Up or down? Are they both up? Yes, they are, because it's even. They're both the same. And because it's positive in front, it's up on the right, and therefore, if it's up on the right, they have to be the same. Must be up on the left also. Okay, good. You covered a lot of stuff. Now, the only thing left is talking about making a sign chart. I'm going to save that for tomorrow, given the amount of time that we have left today. So let's look at our homework for together. And this is part of your assignment right here. We are going to do problems 13, 17, and 18. Might as well get there right now with me. All right, I guess I'll do one of those with you to show you what they're talking about. And here's number 7b. I want you to do this one too. And remember, to make a sign chart like we did before, you want it to be set equal to 0. So one of the things you want to do is get this all onto one side and equals 0, like blah, 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 equals 0. So maybe you should move all this stuff over to the other side. And the other thing is, aren't things that have fractions in them innately harder than things that don't? Didn't I teach you how to clear fractions in the top 20? So would you multiply by something here to clear this fraction? Tell me you would not just multiply by x, because that would not work. What would you multiply by? X squared, because that would be enough to cancel this one, and an x squared on top would allow this to cancel one of your x's, right? So you're going to multiply by x squared everywhere on all the terms. Everywhere. That'll clear up your fraction. And then again, move it all over to equal 0. So the idea of a sign chart is, if this thing equals 0, I set f of x equal to 0, then do you get, if I make just a little sketch of this, I'll know where it's positive and negative. All right, so that tells me one of the roots. What's one of the roots? 2. Everybody put a dot at 2. What's another root? -1. Put a dot there. Okay, now, can you generally, all sign chart really means is, can you sketch this thing? Because once I sketch it, and let's say I do this. Let's say it was like that. Okay, I don't think that's, well, actually, that might be right. But anyway, let's say that I sketch it like this. Can you tell where it's above 0 and where it's not? Do you get that in this little zone in here, the function is above 0 and therefore positive? In this little zone right here, do you get that it's below 0 and therefore the function is negative? Okay, this is what the sign is. You know, sign meaning positive or negative. And in this little zone, it's also negative. At this exact spot right there, it's equal to 0, and at that spot, it's equal to 0. All right, so back to, make a sketch for me. You know what degree it is. You know how the story ends by looking at that -2 in the front. You should be able to make a little sketch. So what is our goal here? Our goal is to provide a rough sketch of the graph. I like to think of it as, even once you have the rough sketch of the graph, you'll know what its sign is, whether it be positive or negative, as opposed to trying to figure out, is it positive in here or is it negative in here? Now you can do that. Let me just show you an example of that. So let's say we pick the spot 4, okay? If I stick in x equals 4 into my function, do you get I can pretty quickly tell if the thing's positive or negative? I'm going to stick a 4 in and see what happens. Because that way, in this whole zone, I'll know if the thing's positive or negative, as in above the line or below the line. So if I'm going to stick in a 4, this will become a 5. This will become a 2. 2 squared is 4. It'll be -2 times 4 times 5. That's going to become, it really doesn't even matter what it is. It's just that it's negative, right? Do you get, therefore, in this little zone, this has to be negative and has to be going downwards in there? It has to be below the line. Because I just checked it and it came out to negative, well, to be exact, 40. So basically, it has to be down low in here. Can't be above the line. I would like to think of it this way. I think this is actually harder than just sketching it and then using a sign chart to test whether you sketched it right. Okay, so did you get that this thing was degree 3? Raise your hand if you knew it was degree 3. Good. Did you know, therefore, that one end must be up and the other end must be down? Okay, and since it's negative in front, we know the ending of the story is kind of sad. So it's going down at the end. So it must be going down at the end. It must be bouncing at the 2, boing, and I must be cutting through at the negative, or at the 1, sorry, and therefore it should have looked something like that. I guessed right the first time I did it. Now, how could I tell if I was right? In this little zone, I could test 4 and see it comes out negative. Yay, I'm below the line, just like I'm supposed to be. Do you get if I test 0, it better come out negative? Okay, so I'm going to test 0 real quick. So I'd like to think of this as checking to see if I did it right. Stick in a 0, stick in a 0. This comes out to 1. This comes out to -2. So it's -2 times -2 squared, which is 4, times 1. And that comes out negative, and that should come out negative. It's below the line. And last, I can test and see if I did this right by sticking in like -2, -2, -2. So you can check to see if you did your sketches right. Okay, your assignment is to do this page, 13, 17, and 18, this one, and one more thing, ladies and gentlemen. You have to do that one, number 34. No, number 33. It's the very last problem in the whole thing. Just remember, the last problem is also assigned. All right, that's all I got for you for today.